Question number 9 from NEST 2021 first shift. This question is from trigonometry. Let alpha and beta be two roots of 3 cos theta plus 4 sin theta equal to 7 upon 2. If alpha minus beta is not an integer multiple of 2 pi, then the value of sine of alpha plus beta by 2 is 4 upon 3, 7 upon 10, 4 upon 25 and 24 upon 25. And well, post the declaration of the results, the NEST authority said that this question discrepancy is found in the question or answer, so this question is ignored for all candidates. But what we will now try to do is we will try to solve the problem and well, find the value of sine of alpha plus beta by 2. Okay? Acha. Now look, let us first write down the given equation. 3 cos theta plus 4 sin theta equals 7 by 2. We will do the typical adjustment, that is the dividing by the root of 3 squared plus 4 squared, which is 5, and then that allows us to write it as 3 by 5 cos theta plus 4 by 5 sin theta is equal to 7 upon 10. Okay, and then we can put this 4 by 5 as, let us say, cos phi, and 3 by 5 as sin phi. Okay, 3 by 5 as sin phi, and then we can write it as a sine of theta plus phi equal to 7 upon 10 sin a cos b plus cos a sin b. So sin a cos phi, sin theta cos phi plus cos theta sin phi, and what will theta be here? Oh, sorry, not theta, phi. Phi will be, look now, sin phi is 3 by 5 and cos phi is 4 by 5, so tan phi will be 3 by 4, so phi will be tan inverse of 3 by 4. Okay, theta, phi will be tan inverse of 3 by 4, and just for our information, this angle is less than 45 degrees, right? Because tan is an increasing function and tan 45 is 1 and 3 by 4 is less than. Okay, we'll take a note of that. Now let us take this equation and analyze it further. Okay, let us take this equation sin theta plus phi equal to 7 upon 10 and analyze it further. Look, sin theta plus phi is equal to 7 upon 10, so theta plus phi automatically becomes sine inverse of 7 upon 10, and therefore theta will be sine inverse of 7 upon 10 minus phi. Okay, which is sine inverse of 7 upon 10 minus, what is phi? Phi is tan inverse of 3 by 4. Okay, tan inverse of 3 by 4. Now this will give us alpha, one of the roots. Now let's do it on calculator here. Let me change it to degrees first. Okay, now degrees. Sine inverse of 7 by 10 minus tan inverse of 3 by 4, and that is 7.557 degrees. Okay, 7.557 degrees. Now the problem is, how are we going to find the other value beta? They are saying this can't be, well, beta and alpha cannot be such that their difference is an integral multiple of 2 pi, right? Now here is my take. What we can say is, if theta plus phi is sine is positive, then there are two possibilities. Either theta plus phi is in between 0 and pi by 2, which we already considered here, or there is another possibility. What possibility is that? That possibility is theta plus phi is now between pi by 2 and pi, because in the second quadrant also sine of any angle is positive. But then how can we get the other value beta? Look, when theta plus phi is in the second quadrant, cos of that will be negative, right? Cos of that will be negative because it is in the second quadrant. So let's consider that. If you know sin theta, can we find cos theta? Of course we can find cos theta. So cos of theta plus phi, okay, cos of theta plus phi is equal to 1 minus sine squared theta's root. So 1 minus 49 by 100 root with negative sign. Okay, so that will be a negative of root 51 by 10. Okay, so what will be theta plus phi? It will be cos inverse of negative root 51 by 10. Okay, and therefore theta will be cos inverse of negative root 51 by 10 minus tan inverse of 3 by 4. That was the value of that we earlier found out, right? This value. Okay, phi is equal to tan inverse of 3 by 4. Now can we calculate theta? That will give us beta now. Okay, cos inverse of negative root 51 by 10 minus tan inverse of 3 by 4. Now that is 98.70, and you may please note that this has obtuse angle. Okay, this is obtuse angle. Now what will we do? We need to find sine of alpha plus beta by 2. Okay, so we want sine of alpha plus beta by 2, which would be equal to, now look, sine of numerator 7.557, let's take it till the third decimal place, plus 98.703 divided by 2. Okay, and what value did we get there? We got it as 0.8. We got it as, well, because of so many 9s there and because of the approximations that we have used, this is equal to 0.8. Okay, or 4 by 5. Okay, 4 by 5. Now obviously it didn't match with any of the options given. 4 by 3 was there, but 4 by 5 was not there. 4 by 25 is there, but nonetheless we have managed to solve this particular problem. Okay, now let's try to do it on graph and see what we get. Okay, let's try to do it on graph and see what we get. The only thing is the graph is going to show us the solutions in radians. Okay, 3 cos x plus 4 sin x minus 7 by 2, and we need to consider its intersections with x-axis. Okay, its intersections with x-axis. Now look here, 0.132 is there, and after that it's 6.415. So if we add 2 pi to 0.132, it will be this angle. Okay, it will be that angle, so that confirms something. And then here's 1.723, and this will be 1.723 plus 2 pi, right? So I will not verify it, you can do that for yourself. Okay, Acha. Now what we can do is, whatever angles that we got as the roots, well, as alpha and beta, those are actually these two angles. Okay, those are actually these two angles. So let us quickly find the degree measures of alpha and beta, right? So 0.132 into 180 by pi, that's 7.56 degrees. Okay, that is 7.56 degrees, and that matches pretty well with this. Okay, that matches pretty well with that. And what about the other angle? What about the other angle? We now need to take 1.723 into 180 upon pi. So that's 98.72. 98.72. Does it match with this? Yes, matches pretty well with that. Okay, so I think what they expected was 4 by 5 or 0.8, but the options were not of that kind. Alright, so, well, these are also principal solutions, meaning in the range 0 to 2 pi. In the range 0 to 2 pi, that's this interval. Okay, somewhere here, this interval. ठीक है. अच्छा. So that is question number 9 from NEST 2021 first shift.